origin of this webinar was a discussion that I had with the air directors and the TOC in a meeting in back in November, I think, where we were showing some work that we were doing at LADCO on using satellite data for looking at ozone formation sensitivities. And there was some discussion around what resources were out there for helping state planners access, understand, and use satellite data. And so that made me think of my friend and colleague, Tracey Holloway, who we're very lucky to have here in our region. Dr. Holloway is a Gaylord Nelson Distinguished Professor at the Nelson Institute of Environmental Studies at the University of Wisconsin-Madison in the Department of Atmospheric and Ocean Sciences. She's a team lead of the NASA Health and Air Quality Sciences team, which is a program to promote the application of remote sensing data, satellite data through partnerships between science and air quality planners. Tracey is an expert on satellite data and using satellite data for air quality planning applications. And she's graciously agreed to talk with us today on some of the insights and knowledge that she has on using these data. So thank you, Tracey, and welcome to the LADCO group here.
Thank you.
I'm going to start just with a couple of slides that I have showing how we're currently using satellite data here in our region to support the planning needs in our member state agencies. And that'll take me 5 or 10 minutes. And then Tracey will spend a half an hour or so going through some slides that she has, and then we'll leave about 15 minutes at the end to answer questions and have some open discussion. I think to allow us to get through our slides, maybe if you could hold questions to the end, that would be helpful so that we can get through everything that we wanted to present today. And then we'll have enough time, like I said, 15 minutes or so at the end for open discussion. So I had presented these slides to a NASA, a variation of these slides at a NASA meeting in the summer. And it was basically making the case that, we're already using satellite data pretty heavily in our work here at LADCO. The meteorology modeling that we do to support the regional scale air quality modeling, the WRF modeling, has satellite data integrated into its solution in many different places. So we assimilate satellite retrieved data into the model to improve the model solutions. And these are some of the products that we're using. Data on soil temperature and moisture, surface reflectance, clouds, temperature, precipitation. We're using something called FDDA. It's multi-dimensional data assimilation to nudge the model solution towards the observations. And it's a really important value-added part of the modeling process. And this is nothing new. It's been going on for a decade or more. But this is a very well-established use of satellite-based information in air quality planning. It may not be obvious, but it's in there. And it's a very important part of what we do with our MET modeling. On the air quality and emission side, we use retrievals of aerosol optical depth and aerosol optical thickness to look at validating the models, understanding where there are aerosols in the atmosphere and the impacts of different aerosol sources. We look at aerosol backscatter for looking at things like vertical profiles of aerosols in the atmosphere. This is important for tracking smoke plumes, for example, or dust plumes. In this region, it's mostly for looking at smoke. We use retrievals of different gases, nitrogen dioxide, formaldehyde, SO2, carbon monoxide, again, for model validation, and also for looking at things like ozone formation and the impacts of different pollution events. Satellites can detect where fires are happening and the size of those fires. So they're really important for developing the inventories. All of our fire inventories that come out of the NEI and EPA are based now on remote sensed fire incidents. Green vegetation fraction, so understanding where there's vegetation, what types of vegetation, when the green out happens in the spring is really important for our biogenic emissions modeling and is also integrated in our models, and land cover and land use. So satellite data are used to spatially allocate the emissions data to modeling grids, in part based on land cover and land use information. So while some of this stuff may be more obvious, like when we show you a map of NO2 or we show you a map of smoke plumes that are based on satellite data, a lot of it may not be obvious, but it's very well integrated. Satellite data is very well integrated in the processes that we use here at LADCO now. And these are some of the applications that we've done recently within the last couple of months, within the last month to year. We've used satellite data for tracking smoke from fires. Exceptional events is something that is all very recent and relevant for us. Looking at air quality episodes and tracking trends. Looking at lake breezes and the extent that the timing and the extent of lake breeze formation and penetration. And this image on the right here shows surface reflectance, and you could see kind of the cloud cover, the light cloud cover around Lake Michigan, and you can actually see that gap between the cloud cover and the lake shore is representative of a lake breeze. And we use this to validate the modeling and also to understand when there might be lake breeze driven ozone events. We use data for establishing boundary conditions for our regional modeling, surface trends, as I mentioned, meteorological data, ozone chemistry. Where else do we hope to use it in the future? We're always looking to integrate satellite data into improving and understanding our emissions inventories, chemical data assimilation. So the same way that we use satellite retrievals of different meteorological parameters to nudge the MET models towards reality, there is active research in also assimilating satellite retrievals of chemical species to nudge the regional models back towards reality to improve the model solution. And then data fusion. How do we combine satellite data with surface station observations, even with sensors, and modeling data to get a fused data product that has multiple data sets integrated into it? I mentioned using aerosol data from a satellite data product called Calypso, looking at aerosol backscatters. These are just some plots showing kind of a transect of the vertical profile of aerosols, where we were looking at smoke plumes coming into the region and whether those smoke plumes were reaching the surface. Calypso is one of the few products, but important products that we have for looking at vertical profiles of aerosols in the atmosphere. And then more recently, you've seen Angie Dickens presenting on the use of formaldehyde, satellite retrieved formaldehyde and NO2 ratios to indicate ozone formation sensitivity. And this plot is basically showing where the satellites see where ozone is NOx sensitive in the cooler colors and it's VOC sensitive in the warmer colors. So with that, I've been talking over the last couple of years about the process for integrating and better integrating satellite data into air quality planning. And there's been actually some work on this. Jana Milford at the University of Colorado had published a paper several years ago now talking about what some of the steps are to better integrate satellite data into air quality planning. There needs to be saliency. The data have to be integrated into the mission of the mission of the Environmental Management and Health Agency. How do you create legitimacy for the data? Really to solidify the use of them in the planning process and make them integral to future forms and guidances that are part of the Clean Air Act. And creating demand for the data. And I think this webinar is kind of a step in that direction. How do you create planning agency friendly processes for using remote sensing data, portals and tools that are easily accessible to allow these data to be used by you all in your day-to-day work. And then also, kind of investing in the paradigm that there needs to be active partnerships between researchers like Dr. Holloway and air quality planners so that they can communicate and hear each other's kind of needs and uses of satellite data and how to kind of bridge some of the gaps that are there. So with that, I'll pass the mic over to Tracey, and hopefully with that introduction, she can run into some more details about how she views the use of satellite data for air quality planning.
Thank you, Zach. And yeah, that was a perfect introduction. And I really appreciate the opportunity to be here and talk with all of you today. I lead the NASA Health and Air Quality Applied Sciences team. We refer to it as HACAST. And this has been an initiative that has been going on for over 10 years now. The first generation of this team was a 5-year initiative led by Danielle Jacob, a professor at Harvard, and I was the deputy director of that first initiative. And the first version of the team was really focused on the US and air quality. And a lot of what we've learned about satellite data and applied science came out of that team, including the paper by Dr. Milford that Zach just mentioned. In 2016, NASA recompeted the team and expanded the focus to health as well as air quality and to global issues as well as US issues. We remain primarily focused on the US and primarily focused on air quality, but we have a little bit of a broader mission. And that second team ran for 4 years through 2020. And I was the director of that second team. And then the third team was just recompeted last year and is a 4-year team, which I'm leading now. So that's why we call it the third generation. And we've learned a lot and grown a lot of partnerships. And it's just been a real pleasure to work directly with LADCO, really since the very beginning, and the Wisconsin Department of Natural Resources and many other state partners in our region. So I'll get started with an overview of satellite data, tell you a little bit about NASA's investment in this team, which is really intended to be a bridge linking remote sensing capabilities with the needs of organizations. And I hope through that conversation, if any of you have ideas about how satellite data could support your state's activities, please don't hesitate to reach out to me personally. And then I'll talk a little bit about some successes around satellite data in air quality management, some resources, and maybe some trends that I see coming around the corner. So to start out, when we're talking about satellite data for air quality, there is a whole constellation of instruments up in space and more instruments being launched, not quite every year, but almost every year, that are relevant to air quality detection. These instruments are part of NASA's investment in what they call Earth observations. Of course, for those of us on Earth who study air pollution on Earth, everything that we look at is an observation of the Earth. But from a NASA perspective, they often call these Earth observations to distinguish it from observations of Jupiter. And they have a portfolio of Earth observations, including satellite data and including some ground-based sensors, like a Pandora instrument that can look up through the atmosphere, has been an example of the kind of capabilities that NASA has been embracing. Here, I'm just going to focus on satellite data, which are one of the most powerful tools in the NASA toolbox relevant for air quality, because now satellites can see gases and particles in the air that are invisible to the human eye and that are relevant to air quality management and planning. The good news is that these data are free, publicly available, and most of them are available every day for the whole Earth. So it's a pretty amazing resource. The bad news is that it isn't apples to apples comparison with ground-based monitors. The data are not available when there's cloud cover in the sky. And the resolution is coarser than what you get from a ground-based monitor. So there's a little bit of quilting together data sources that is needed to effectively use satellites in an air quality management context. And one of the activities that we've been engaged in for over 10 years is trying to understand where are there opportunities where satellite data can play a role in a way that's constructive and useful, and not trying to force the data to be something that they are not, because they're certainly not, for example, a substitute for ground-based measurement. A couple of months ago, I contributed a paper to the special issue of EM magazine that was focused on satellite data for air quality. And I'm going to give you here kind of a Cliff's Notes version of that article, which was really 4 things to know about satellite data for air quality management, a very basic starter guide. And one is that satellites have a variety of instruments on them. And one of the tools that is the most intuitive and very relevant for air pollution analysis is visible images. These are called, in NASA speak, true color images. And they are basically what you get if you have a photograph, a camera up in space. And one example here are smoke over Lake Winnipeg, true color image. And these can be useful for air quality management, but usually only for really high smoke events that you can see with your eye. But there are many products that are relevant to air quality management, and 2 of the most widely used are tropospheric NO2, which you see on the left, and aerosol optical depth, which is an indicator of particulate matter in the atmosphere. I'll be talking more about both of these, but I'll just get started here with these 2 examples. You may have seen the image on the left, which is tropospheric NO2 over China before and at the peak of the lockdowns in early 2020. And you can see that there is more pollution in the left panel and less on the right panel. NO2 has become kind of the darling of air quality applications from satellite data because the satellites can see it fairly clearly and with high resolution. And because the atmospheric lifetime of NO2 is short, the column of air that the satellites see is a pretty good indication of where the emissions are coming from and the spatial patterns that we see on the ground. So oftentimes when you see satellite images of air pollution, it ends up being NO2. Aerosol optical depth, it can be used as an indicator of particulate matter. And what you see here on the right is a global map where you see high values over Canada due to forest fires, high values over northern Africa due to dust from the Sahara. You see high values in the southern part of the African continent due to biomass burning, and high values over the Middle East and East Asia due to dust storms and biomass burning, as well as residential and urban fuel use. So there's different products that fit together in different ways. And I'm not going to spend too much time on this table, but I wanted to kind of outline the themes that I'll be talking about through the next few minutes. First, that many people say, well, what can we see from satellites? And really the answer is 3 big gas phase pollutants, NO2, SO2, and formaldehyde, indicators of PM 2.5. We cannot see ground surface ozone, but we can see stratospheric ozone. So you'll often see instruments that actually may even have ozone in the name. But these typically were designed to monitor stratospheric ozone. And in fact, satellites have been monitoring stratospheric ozone since 1979. And that's one of the best sources of information we have on what's happening with the ozone hole over Antarctica. But we don't have any satellite data directly of near surface ozone. We can inform that with formaldehyde and NO2, but I think one of the holy grails that everybody would like to have is satellite data of actually what the ozone is near the surface, and that's just not available. There are other data products that are growing in relevance to air quality management, including ammonia as an indicator of ammonia emissions. Carbon monoxide is helpful to look at long-range pollution transport. But really, most of the time when you see satellite images, it will either be of the three gases, NO2, SO2, or formaldehyde, or it will be aerosol optical depth as an indicator of PM 2.5. There are a couple of different instruments up in space that can measure the gas pollutants, NO2, SO2, and formaldehyde. The best, highest resolution that covers North America and the whole world actually is called the TROPOMI instrument, and that was launched by the European Space Agency. That was launched where the first year of data is available for 2019 and onward. So it's great for getting high resolution images, but it doesn't give you those long-term trends. When you see analyses of long-term trends in air pollution, that's usually coming from the OMI instrument, and that was launched back in 2004. So we have annual data since 2005. The good news is that next year, NASA will launch a new instrument called TEMPO, and that will provide hourly data over North America at a higher resolution. So the best available now is TROPOMI, but it will get even better next year. And these data have been used to look at ambient NO2 and estimate that, looking at emission trends, emission patterns, evaluating models, and considering sort of short-term changes like the COVID lockdowns. PM 2.5 has been estimated from this aerosol optical depth indicator using fused data that takes models and ground-based instruments and satellite data together. Aerosol optical depth alone can be used for tracking smoke plumes and dust storms, exceptional event demonstrations. But as you start combining satellite data, models, and ground instruments, you can do even more. And then Zach mentioned the ratio of formaldehyde to NO2 as an indicator of ozone sensitivity, and I'll be talking more about that in a few minutes. So one characteristic of satellite data that's important to know is that they really see the column of air from the surface up. These satellites are up in space looking down, so they really don't have a very good ability to detect the vertical distribution of pollution in the air. So what you see tend to be two-dimensional images that reflect the column abundance, as we often refer to it. So if the pollution is coming mostly from the surface, like NO2, then the column may be a good indicator of what's happening at the surface. But if the pollution is coming from higher up in the atmosphere, for example, a plume of wildfire smoke, then you may have high levels of satellite abundance, satellite detected abundance, but that may not agree with what's happening at the surface. So I think the interpretation of satellite data requires this kind of column thinking, which is different than a monitor. Most satellites provide snapshots once a day for every location on Earth. And that makes them a very powerful tool for air quality management, not just in the US, but around the world. Most countries don't even have a single monitor. And they can be used to look at long-term trends and sometimes even episodes. But because they only have one snapshot a day, you're not getting full day coverage. And if you have clouds, like in my image here on the left, then you have no data whatsoever. And that may be, you also don't have data if you have snow on the ground or such high levels of, say, smoke here that it's obscuring the satellite and kind of acting like a cloud. On the right is this distinction between polar orbiting satellites, which cover the whole Earth. And that's what most air quality relevant satellites are now, and what are called geostationary satellites that orbit with the Earth. And I mentioned that TEMPO instrument would be coming online next year, and that will rotate with the Earth, and that's why it's able to provide hourly data over North America. The good news is getting started is easy, and we've tried to make our website for our team, which is has the URL of just our acronym, haycast.org, with resources to be a front door for air quality managers and other stakeholders. So we have getting started, data and tools, and then there's links to training and other resources. So I'll be talking more in the next few minutes, but I think sometimes that there's so much terminology and technical specifics about the satellite data that it can seem overwhelming, but there are actually a lot of very user-friendly resources from the NASA Earth Observatory that is kind of like a museum of satellite data with stories to go along with the images, to, for example, NASA Worldview. This left panel here, shown as Figure 4, is a screenshot from NASA Worldview, which allows a visual interface to navigate different pollutants and days. So when I first started working with this NASA team back in 2011, one of my collaborators was Bart Sponseller, who at the time was the monitoring section chief for the state of Wisconsin. And in fact, at our first meeting, Wisconsin was the only state that had a attendee at the meeting. And I think there was a lot of feeling and discussion about how state air quality managers were an audience that we needed to connect with more. And we've really made a big effort over the past 10 years to grow connections. And I hope that those of you who are on the call today who see some potential relevance, feel free to engage with our team. And of course, we've been working with LADCO, with RAP, with NESCOM, with Marama, and with other regional planning organizations. But Bart had this slide about the potential monitoring site purposes that he often used in explaining why the state had a monitoring network. And I thought this was a nice starting point to think, can satellites do that too? And the number one reason why we have monitors is to determine compliance with the National Ambient Air Quality Standards. And that is really the one thing that satellite data cannot do, because they do not detect near surface concentrations. However, they definitely can play a role in most of the other activities that we currently use monitors for, from developing pollution trends, evaluating the effects of different pollution contributors on air quality, evaluating models, and providing information to the public. So our team, HayCast, was set up to be a bridge connecting NASA data and tools with stakeholder interests, and using the needs of different stakeholder organizations to inform the activities and the research of our team. Sometimes I joke that I'm like a salesperson trying to sell billions of dollars of data for absolutely free to any organization that could find it useful. And right now, our team has 14 members that were all selected through a NASA peer review competition. And each of the 14 proposals has multiple co-investigators. So all told, we have about 70 or more people working on the team. And we have activities led by each of those 14 team members. We have collaborative activities that NASA calls Tiger Teams. And we also put a lot of effort into outreach and engagement to make sure that new organizations can contact us and join and be part of our initiatives. I mentioned that this tracks back and that we're in our third generation. And what we found is that by having a team of researchers, we can increase the visibility of our work and build a culture of collaboration that allows our team to respond to real world challenges. Because we don't want a state air quality manager to have to figure out of all the different scientists on Google, who is the right person to ask a particular question. We want to be a front door, and we're happy to matchmake if it isn't a question that we already have an answer to. And it may be a question that nobody has an answer to and would be a great research project. And so that's exactly the kind of initiatives that our team moves forward. Our current team, I mentioned, has 14 PIs. These range from university professors in health and air pollution to researchers at government labs from Alaska to Florida. And I'm going to sort of pivot now to some success stories with satellite data. And I think one that we cite a lot is the inclusion in the EPA Air Trends Report, which has been going on now for a few years. And most recently, they have included NO2 data in their Air Trends Report. I think their last Air Trends Report had a similar plot, but for SO2 data. And in all cases, the satellites really are a compelling visual indicator of air pollution going down, down, down due to air quality management over the past 50 years. This inclusion in the EPA Air Trends Report led to us having conversations with the Wisconsin Department of Natural Resources, and we now put the same data in the Air Trends Report for Wisconsin. And certainly if any of you want to include the Air Trends data like this in your own state reports, we're happy to provide that. Another example of satellite data in air quality management comes from the Northbrook Exceptional Event Demonstration that was submitted in December and the EPA's response. I pulled images from the Alpine Geophysics report for the IEPA, and these are the 4 images on the right, as well as the EPA's response on the left. And what you see here is in the upper left quadrant, those images are of NO2 from the TROPOMI instrument. That's the highest resolution NO2 instrument that I mentioned. You see in the upper middle an example of visible imagery being used for as part of this exceptional event demonstration. On the right, you see aerosol optical characteristics from the Calypso instrument, which shows, that's one of the very few instruments that shows the vertical distribution of particles in the atmosphere. Then all 3 lower panels show this aerosol optical depth, AOD, this indicator of particles in the atmosphere, but taken actually in this case from 3 different instruments. There are a lot of different instruments up in space that measure aerosol optical depth. And the center image was actually just a screenshot of that NASA Worldview website that I mentioned earlier. Zach highlighted the interest in the ratio of formaldehyde to nitrogen dioxide as an indicator of ozone sensitivity. And I find this one of the most exciting applications of satellite data because it's really informing decision-making in terms of whether NOx controls or VOC controls might be more powerful in reducing ozone. And actually, when these applied science teams first started back in 2011, one of our early meetings was in Madison, Wisconsin in 2012. And one of the attendees was Pat Reddy, who was an air quality manager from the state of Colorado. And he mentioned to me just over coffee that he had used the ratio of formaldehyde to nitrogen in a briefing to their county planning commission or their state planning commission, because there was dispute about whether in the Front Range of Colorado, ozone was NOx limited or VOC limited. And because they did not have enough NOx and VOC monitors to answer that question, he replicated a study that had been done by a colleague of mine named Brian Duncan using OMI data on NO2 and formaldehyde. And he used that analysis to highlight that the belief and analysis of their organization that ozone was NOx limited in the Front Range. And to my knowledge, that was the first air quality management application of this formaldehyde NO2 ratio. And we wrote it up in 2014 in a special issue of EM as a case study of how this ratio could be used to support ozone sensitivity assessment. And shortly after that, I had a graduate student named Xiaoming Jin who worked with me at the University of Wisconsin, and I was excited about pushing this indicator further. And so for her master's at Wisconsin, Xiaoming applied this ratio over China. And in that work, she framed it in this way of actually plotting the ratio as NOx limited, NOx saturated, and here red, and in the middle as orange, transitional. And Xiaoming went for her PhD to Columbia University and continued her work. And that is what is being highlighted here by NASA, her continuation of this work using satellite data for ozone sensitivity. And Xiaoming is now a postdoc in California, but her work remains the most advanced analysis of how this ratio of satellite data should be used for ozone sensitivity. Another exciting application of satellite data is ammonia emissions, because ammonia is an ingredient for particulate matter formation, but there's a lot of uncertainty about emissions. And there's two instruments up in space that can detect ammonia, and they've been used to look at the seasonal variability within the United States and on a global basis. And in early 2020 and late 2019, I was working with the EPA to put together a workshop. It was canceled due to COVID, but initially the goal was to highlight areas where there was the most potential for satellite data to support the decision-making and activities of the EPA. And ammonia was definitely high on the list of topics to be included in that discussion, because accurate emission inventories of ammonia are an area where satellites could really contribute. We already talked about the public outreach and scientific analysis questions associated with short-term changes in NO2, like over China in early 2020. And I wanted to bring your attention here to a website that was developed over the course of our HACAST generations. But this is the first website that NASA has on air quality. And within this air quality website from NASA, which the URL is at the bottom of my screen here, and it will stay here through the next couple of slides, there's different categories, so you can look at pollutants and impacts, but there's a special category on managers, because you all, air quality managers, are a major audience that NASA wants to make sure that the data are getting to you in a way that you can use and feel supported. And so within the manager section, there's some information on state implementation plans and guidance that came out of our teams on satellite data for SIP analysis. And so what, you may wonder, can NASA help me with? And so our team has developed 4 guidance documents, and I'll step through these. One is a guidance document on exactly what we've been talking about, the use of satellite observed formaldehyde to nitrogen dioxide as an indicator of ozone sensitivity. And so we have we're viewing these as kind of a recipe so that air quality managers know what data to use, how to interpret it, and have a reference to cite. So on this website, you can click it and then there's a guidance document. 3 other guidance documents are how to use data, NO2 data from the OMI instrument, and that's the one that's especially useful for looking at trends and characterizing the decrease in NO2 due to NOx emission controls. Support of exceptional event demonstrations, which we've also discussed in the context of Northbrook, and evaluating photochemical grid models, especially CMAC. And actually, pretty much every satellite data product can be used to evaluate CMAC, but because NO2 is one of the most sensitive instruments and relevant for NOx emissions, it's been compared with CMAC more than any other data product. So we talked about what's kind of already out there. In my personal opinion, kind of what's coming out around the corner and trends that are being reflected in current activities. I think one is the growing normalization of satellite data for trends assessment, emission inventories, model evaluation, public outreach. What, you know, a couple of years ago might have been an innovative application, I think is going to become more and more the norm. There's a very rapidly growing emphasis on satellite data for environmental justice applications. This is a priority of NASA. They have a solicitation out right now, in fact, focused on funding work linking satellite data with environmental justice. And just to give you kind of an example of a paper that came out by Gage Kerr earlier this year, looking, and here you see Detroit, and at the top, it's plotting within the city of Detroit what neighborhoods had more or less reductions in NO2 during the lockdowns of 2020. And how do these neighborhoods compare with household income in the middle panel and white and non-white populations in the lower panel. So I think you can see here what high resolution data are available for NO2 and how it can be used to analyze trends within patterns within a city. I think you're going to see a growing use of satellite-derived PM 2.5 to inform unmonitored areas. And this is both on a global basis. Satellite-derived PM 2.5 are used, for example, in an analysis called the Global Burden of Disease, which ranks all factors affecting cause of death around the world. And since most countries don't have any monitors, if you want to compare different countries and their air pollution, these satellite-derived PM 2.5 are a powerful data source. But they're also being used within the United States. And there have been a couple of different reports, mainly by economists, but who are using publicly available data from satellite-derived PM 2.5 to look at how that compares to monitored PM 2.5 and NACS attainment. And, you know, I'm working, for example, with the American Lung Association to say, could satellite-derived PM 2.5 support their activities? And, you know, I'm not sure if it will ever be in the State of the Air report, but those are the kind of questions that we're looking at. And, you know, and I'd say a final trend is that health and community organizations may be exploring satellite data along with low-cost monitors to increase spatial coverage of air quality information. We've been having a lot of conversations with cities, with nonprofits, with health organizations who, you know, are excited by the possibility of complementing air quality information from regulatory monitors. And I think that that's sort of a shift, because for many years, all the air quality information always came through the state agencies. And so I think that that's kind of a change, and I'm not sure where it's going to go, but I'd say it's something that seems to be kind of on the horizon. And so I'll end with an invitation. We have a meeting that was supposed to be in Houston, Texas, but due to Omicron concerns and the American Meteorological Society going all virtual, we have moved to an all virtual meeting as well. So next week, January 20th and 21st, we'll be having a series of panels and presentations discussing different aspects of satellite data for public health and air quality management. And I would invite you to join us if you are interested. So I'll stop sharing my screen and be available for any questions.
Thank you so much, Tracey. That was a great overview. That was a lot of information. You covered it right on time. So I appreciate you sticking to the schedule so that we could have some discussion now. I see that Jay Olaguer from the state of Michigan and the Michigan Eagle Agency has his hand up. Jay?
Yeah, Tracey, thank you for your wonderful presentation. I have a question about the formaldehyde to NO2 sensitivity derived from satellites. How does the assumed vertical profile of formaldehyde versus that of NO2 constrain or limit the use of that ratio?
Yeah, it's a very good question, and I think it's there's a few different aspects here. One is that different. I'm hearing a little bit of I don't know where that's coming from, but I hear different instruments are sensitive to different vertical areas of the atmosphere. So one, no satellite is super sensitive to what's happening at the surface. And there's really the question of how much of the overall column is controlled by what's happening at the surface. And I think in the case of NO2, most of the NO2 in the column exists at the surface. In the case of formaldehyde, that's not necessarily true because a lot of formaldehyde is created in the atmosphere through chemical reactions. So I think one issue is how sensitive the instrument is to different layers. Two is how NO2 versus formaldehyde are distributed in the different layers. And then three, like what is the magic number for that ratio? And the initial study that used OMI data for this was done by Brian Duncan in 2010. And they used, I think, CMAQ data over California to come up with, that a ratio of 1 was one threshold and a ratio of 2 was another threshold. And that now I think is quite outdated. But understanding what the right ratio should be and in what context, that's something where the research has been coming out just in the past couple of years. And I think really LADCO is on the cutting edge in terms of trying to interpret these ratios with respect to models and with respect to measurements. And it's been nice to have the Lake Michigan ozone study that offered kind of a full package of observations to be pulling the pieces together. And I know actually I'm on the committee of Gerald Ochdon at the University of Wisconsin, who's working with Zach and others at LADCO to analyze exactly your question, Jay. How representative are these ratios? So this is all a long way of saying, I'm not sure, but so far it's been the only data source that we've had over much of the world on the ratio and the relative impacts. So I think at a minimum, it's a screening tool. At a maximum, if it was applied and refined in the right way, it could be, something that could fill in some gaps.
Thank you. Thank you very much for your answer.
Thank you.
Bob Hodenbosi from Ohio EPA has a question.
Great. Thank you for your time, Dr. Holloway. This is just a great presentation. My question is a little bit off topic, just a little bit off topic. Your focus this afternoon was great. It was on air quality associated with the ambient air quality standards and all. My question is methane detection from satellites. And I know there are satellites up there that are looking at methane leaks and all. Do you have a contact, or is there some way that state agencies could have access to that information?
Yes, 100%. Actually, the leader of the NASA, I forget the exact name of the group, but it's the group that looks at methane from satellites, is Danielle Jacob, who is a professor at Harvard. And he wrote to me just a couple weeks ago saying he wanted to connect with air quality managers who were interested in methane, and who did I know that I should connect him with. So of course I connected him with Zach, but he would be very happy to connect with you. Yeah, but I wanted to just say, in addition to introducing you, Bob, the one thing about methane, which is a little bit funny relative to other pollutants, is that, you know, there are some private companies that have satellites that are neither polar orbiting nor geostationary, but instead deployable. Like they can zoom over to the part of the Earth and take high resolution measurements. And so sometimes, like one of these is called GHGSat, and then the Environmental Defense Fund is launching another one. And so there's, you know, with methane detection, there's kind of an extra category of satellite data, which is focused on specific leaks. So there's your global data, kind of like I've been showing so far, but you also have this sort of second category of these kind of focused investigations into methane leakage.
Okay. Thank you. And Zach confirmed he has the information, so we're all good.
Yeah, I'll loop you in. I have a question about SO2. You know, its ambient concentrations have been decreasing, thankfully, for, you know, those of us living at the surface of the Earth. And it seems that the utility of the satellite-derived SO2 products are kind of waning because of the detection limits of the instruments. Is that a correct interpretation?
I would say I would have agreed with you a couple of years ago, but actually there's new instruments that are able to detect quite low emissions, and like the newest instrument is called, or it's not an instrument, but algorithm is called Cobra, and that's being used with the Tropomi algorithm, and they are able to detect you know, higher than, for example, the 2,000 tons per year threshold that was used to determine the DRR list. Like the instrument, for comparison, the annual detection limit is 4,000 to 8,000 tons per year with the detection of the Tropomi. But, you know, actually, like my team's been doing some analysis and of SO2 emissions, and even though an individual facility emitting above 2,000 tons is already on the DRR list, there are a lot of clusters of SO2 emissions that cumulatively emit amounts that are getting into the detection limit of the SO2 algorithm. So I think, you know, in the US, you know, it's true that SO2 is going down and that the satellites are not as sensitive. But we actually have a proposal into NASA right now that is proposing using the SO2 data to look at clusters of SO2 emissions in the US. That's the US story. I think around the world, you have power plants that are emitting at a much higher level where satellite image is relevant. And actually, there was a paper that came out a few years ago tracking I believe it was like a metal smelter or something in Russia where, you know, the emissions had been going up, 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 and the satellite showed them as going up, up, up. And then there was a big outcry, and then the official estimates of SO2 from the smelter showed it going down, 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 but the satellite showed it continuing to go up, 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 up. So I think this idea that, you know, as instruments, as algorithms are advancing, they may be relevant in the US for clusters of SO2 emissions, but they're certainly something that in many other countries can still be very air quality management appropriate.
Thank you for that. And the context for that is I'm thinking about a potentially lower PM 2.5 standard. You know, something that EPA is considering now, and you know, we have NO2 retrievals, we have the ammonia retrievals, and if SO2 will continue to be a reliable retrieval, that will be a really important planning product to have at our disposal if that standard does get lowered.
Yeah.
We're almost at the top of the hour. Any last questions for Tracey? Okay. Would you mind sharing the slides that you sent? There were some URLs on there that I think would be really useful to get a hold of, Tracey.
Absolutely, Zach. I'll send those to you, and then I'll also send a link to our upcoming meeting next week.
Mm-hmm.
And also then everybody will have my email, and I would really, you know, I am happy to work with any organization around the world on air quality and health, but I especially love to work with organizations in the upper Midwest since we're all neighbors. So please don't hesitate to reach out.
Great. Thank you so much, Tracey.